Okay, in 5.3, firstly I want to talk about the definition of inverse of a matrix. Okay, now let me start by giving you a situation. Let's say you are given 3 over 2 here, and its inverse is 2 over 3. Okay, let's say this is A and this is the inverse of A. And then when we multiply these two values, it will give you 1. And now I will change the position of these two values, where 2 over 3 here is multiplied by 3 over 2. And as you can see here, 2 over 3 is the inverse of 3 over 2. And it also gives you the similar value. And from this situation, we can say that when A is multiplied by its inverse, and it will give you 1. And same goes for the inverse of A is multiplied by A, it also give you 1. And 1 here is called identity. And then this concept is applied for matrices. For a square matrix A, the inverse is written as A with superscript -1. And this notation is not 1 over A. Okay, when you are given 2 to the power -1 in real number, then it will give you 1 over 2. But this situation is not applicable for matrices. Okay, when you are given A with superscript -1, then it is called the inverse of matrix A. And we need a special process to find the inverse of matrix A. Okay, next, when A is multiplied by its inverse, then the result is the identity matrix denoted by I. And non-square matrices do not have inverses. Only the multiplication of A and its inverse, okay, is commutative. If you still remember in previous slide, okay, the properties of multiplication, okay, multiplication of matrices is not commutative. As you can see here, matrix A is multiplied by matrix B is not equal to matrix B is multiplied by A. That's why in this case, please remember only A and its inverse is commutative. Okay, now look at example 22. Okay, you are given two matrices here. And then as you can see here, the multiplication process is carried out. And as you can see here, when matrix A is multiplied by matrix B, okay, we can see that the resulting matrix here is identity matrix. And then same goes for the situation when matrix B is multiplied by A. Okay, so we can see that, okay, the resulting matrix here is identity. And from this situation, we can say that when matrix A is multiplied by matrix B is equal to matrix B when it is multiplied by matrix A, and it gives you identity matrix, then we can say that matrix B here is the inverse of matrix A. Okay, now I want to show you the process of getting the inverse of a 2 by 2 matrix. Okay, now let's say you are given matrix A and then matrix B, then matrix B is multiplied by matrix A. So as you can see here, this is B, this is A, and then this is the resulting matrix. And we can see here at row 2 column 2, the element here is actually AD minus BC. Then this one is equal to the element at row 1 column 1. Okay, as you can see here, then we can factor out AD minus BC from the matrix. And as you can see here, we have AD minus BC is multiplied by the identity matrix here. And then now I want to make the identity matrix here as the subject. So I will remove AD minus BC on the right hand side by multiplying both sides with 1 over AD minus BC. As you can see here, 1 over AD minus BC. Then from this process, we can see that 1 over AD minus BC multiplied by AD minus BC, it will give you 1. On the left hand side remains the same. Okay, and next, as you can see here, on the right hand side becomes identity only, and then on the left hand side, okay, we have matrix A, and then matrix B, and then this scalar. Okay, so what we can say here, by applying the process, the inverse of matrix A is multiplied by A is identity matrix. Then we can say that to get identity matrix of this part, okay, A here must be multiplied by the inverse of matrix A. So we can say that if this matrix is A, then the whole part here is called the inverse of matrix A. And then from these equations, we can say that the inverse of matrix A is obtained by finding 1 over AD minus BC, and then multiplied by, okay, to get this matrix, okay, I will exchange the position of A and D becomes DA, and then I will reverse the sign of B and C becomes negative B and negative C. And now, as you can see here, okay, the terms AD minus BC is actually the determinant of matrix A, where A here is the matrix with element A, B, C, D. And then to get the determinant of this 2 by 2 matrix, you must refer the previous slide. And as you can see here, we can apply the process for finding the determinant here is AD minus BC. Then this one is actually matrix A. And then what we can say from these equations, okay, the inverse matrix here is equal to 1 over determinant of matrix A multiplied by the matrix with element D, negative B, negative C, and A. So to find the inverse of a 2 by 2 matrix in general, okay, when you are given matrix A with element A, B, C, D, then the inverse of matrix A here is obtained by finding the value of 1 over determinant of matrix A, and then multiplied by 2 by 2 matrix here. Okay, and then to get this 2 by 2 matrix, we interchange the element of leading diagonal, AD here becomes DA, and then reverse the sign of the other element, which becomes negative B and negative C. Okay, now look at example 23. You are given matrix A with element 2, 5, 1, 3. Then to get the inverse of matrix A, then I will start by finding the determinant of matrix A. So in general, if matrix A is given by A, B, C, D, then the determinant of matrix with element A, B, C, D here is given by A times D minus B times C. So now to get the determinant of matrix A here, I will apply 2 times 3 minus 5 times 1. Then I will get 6 minus 5, and then the determinant of matrix A here is 1. And then I will substitute this value, okay, in the inverse formula. So I will get the inverse of matrix A here is given by 1 over determinant of matrix A, which is 1. Okay, multiplied by a 2 by 2 matrix here, where this 2 by 2 matrix here comes from matrix A. We need to interchange the element of leading diagonal from 2, 3 becomes 3, 2, and then we will reverse the sign of the other element. Okay, so negative 5 here becomes negative 5, and 1 here becomes negative 1. Then we can see the inverse of matrix A here, okay, is given by 3, negative 5, negative 1, and 2.